Welcome everyone. In this video I will talk about how to solve linear differential equation by the method of undetermined coefficient. I am uploading videos related to different topics in mathematics. In case if you are new to the channel, subscribe it and share with all your friends so that they also get better quality content. So let's start. First of all, if I talk about method of undetermined coefficient, it is a method to find the particular integral. We know that when we are solving a non-homogeneous system of linear equation, we write the solution as y is equal to complementary function plus particular integral. How to write the complementary function, that we already have discussed in a detail in my previous videos. So in case if you have not watched them, watch them in the sequential order. And here I am going to talk about how to find the particular integral and will be solving problems related to that. So the process of finding the particular integral actually based on selecting a trial solution, right? And that trial solution is selected on the basis of what is there in the right hand side of the equation. So if the right hand side of an equation is e to the power mx or an exponential function, then the trial solution will contain c into e to the power mx, right? Similarly, if the right hand side is sin mx or cos mx, the trial solution will contain a sum of or a linear combination of cos mx and sin mx. If the right hand side is a polynomial of degree m, then the trial solution will be a general polynomial of degree m. When I say general polynomial, by that what I mean that we have the terms of all powers of x. Similarly, if we have the right hand side as e to the power ax cos bx or e to the power ax sin bx, in that case we select the trial solution as e to the power ax c1 cos bx plus c2 sin bx. If we have sum of these, then we take the trial solution accordingly. For example, if the right hand side is e to the power mx plus sin mx, then we will take the trial solution corresponding to this as c e to the power mx, and trial solution corresponding to this is suppose I am using a constant like a cos mx plus b sin mx. Okay. One thing that I want to highlight here, that some of you might be thinking that how these trial solutions are actually written, or why we are writing the trial solution like this. So it is based on just the fact that if you differentiate e to the power mx any number of time, if you differentiate it once, you will get m e to the power mx. If you differentiate it twice, you will get m square e to the power mx. So the end product, no matter how many times you differentiate, will be e to the power mx multiplied by some coefficient. Similarly, if you talk about sin mx or cos mx, if you differentiate it any number of time, what you will get? Either you will get cos mx or sin mx. What I mean is that suppose I take sin mx and if I differentiate it, I will get m cos mx. Okay. I differentiate it again, so I will get minus m squared sin mx. I differentiate it again, so I will get minus mq cos mx. So as you can see that no matter how many times you differentiate sine, only expected outcome is either a cos term or a sine term. So that is why when we are writing the trial solution, we are taking the combination of both the possible differentials that is possible for sin mx or cos mx. If you look at x to the power mx, here also you can clearly see that if you differentiate x to the power mx, you can get the terms of x to the power mx, x to the power m. For example, if I take x to the power 3, if I differentiate it once, I will get 3x square. If I don't differentiate it, means zero order derivative, it will be x to the power 3, means if I just multiply it by a constant. If I differentiate it 2 times, I will get 6x. If I differentiate it 3 times, I will get 6. So when we write the trial solution, we take the possible combination of all its differential or the function as such, right? Same argument can be given for this function also. In case if you are getting confused, don't worry, I will take examples. What I expect from you, that you will remember that if the right hand side is like this is how the trial solution should be written. But there is one important thing that you need to be aware about, that if any term in the choice of trial solution or particular integral, because to actually why I am selecting the trial solution, I am selecting the trial solution to get the value of particular integral. So if any term in the choice of particular integral is also a solution of the corresponding homogeneous equation, right, that is a term in the complementary function, then we multiply this term by x or by x to the power m if the term in the complementary function corresponds to a multiple root of multiplicity m. If Rx is the sum of number of functions, then contribution with respect to each of these terms is included in the choice of particular integral. By now, what I have discussed possibly might have made lesser sense to you, but it will be clear if you keep watching the video till the very end. So just be with me. I will explain through multiple examples. So I am going to take the very first example, and the first example is suggesting that use the method of undetermined coefficient and find the general solution of this differential equation. So as we know that how to write the general solution is written as complementary function plus particular integral. Now to write the complementary function, first of all we have to write the auxiliary equation. So what is the auxiliary equation? The auxiliary equation is m square plus 1 is equal to 0. So that will give me m is equal to plus minus I. Okay. Now if m is equal to plus minus I, then the complementary function will be a cos x plus b sine x. I have deliberately selected the coefficient as or arbitrary constant as a or b, because in the trial solution I will be selecting c0, c1, c2, etc. So this is the complementary function, right? But we have to find the particular integral. So to find the particular integral, we select a trial solution, or we select a particular integral like ypx. This ypx just signifies that this is the particular integral part of the general solution. Sometimes people write cf as ycx also to highlight that this is the complementary function part of the solution y. So what is ypx? If you look at the right hand side, and this is what I was telling you earlier, that right hand side is a function of degree m, or a polynomial of degree m, right? I repeat it. So here the right hand side is a polynomial of degree what? Polynomial of degree 3. So the trial solution will be a general 3 degree polynomial. General 3 degree polynomial means c0 x to the power 3. So it will be having a term of degree 3. It will have all other terms of degree less than 3, means it will have term of degree 2, it will have term of degree 1, and it will have a constant term. Okay. One thing that I want to highlight here, that here the right hand side was 32x cube and it was a polynomial of degree 3. So I have selected a polynomial of degree 3. If right hand side is suppose 32x cube plus 5x, so in that case also I have to select the same trial solution, because we are not looking at the polynomial as such. What we are looking at is what is the degree of this polynomial. The degree of this polynomial is 3, the degree of this polynomial is also 3. So in case here the right hand side is 32x cube, I have selected this as the polynomial. If the right hand side is this, then also I will select this polynomial or this trial solution. If right hand side is 32x cube plus 5x plus 9, then also the trial solution will remain same. Trial solution will not change because each of these three right hand side, if I may take, will be seen as a polynomial of degree 3. Okay, so selecting a trial solution is based on the degree of the polynomial, not on the idea that what is the polynomial actually is. Okay, now when we write the right hand side, when we write the trial solution based on the right hand side, we also verify that whether any term of this trial solution is already present in the complementary function. So we see that there is no x cube term present here, there is no x square, there is no x term, and there is no constant term. So there is no problem. What if it is present? That I will explain in the coming problems. So right now, if you look at the trial solution, and how did I write the trial solution? I wrote the trial solution by looking at the right hand side. And what is the right hand side? A polynomial of degree 3. If we have a polynomial of degree 3, we write the trial solution as a general polynomial of degree 3. By that what I mean, that it should have all the terms, degree 3 term, degree 2 term, degree 1 term, and constant term. Okay, now the next task is to find this constant or this coefficient C0, C1, this is C2, C1, C0, C1, C2, and this is C3. What I have done, sorry, C0, C1, C2, C3. So this is what we have to find. We have to find C0, we have to find C1, we have to find C2, we have to find C3. Mistakenly I have written C0 and C1 twice, so ignore that. I hope you understand that there are 4 coefficients which are not known. So that is why this method is known as method of undetermined coefficient, because the 4 coefficients C1, C0, C1, C2 and C3 are undetermined, which we have to determine. So how can we determine? I am calling this solution as a trial solution, means this should satisfy the given differential equation. So yp should satisfy. So if yp is satisfying, to satisfy the equation, I need to find yp double dash. So for that, first we have to find yp dash. So that will give me 3 C0 x square plus 2 C1x plus C2, and we have to find yp double dash. So that will give me 6 C0 x plus 2 C1. So now I have to substitute in the given equation. So if I substitute it in given equation, I get what? I get 6 C0 x plus 2 C1, that is the y double dash part, and then y. So in place of y I will put yp, that is C0 x cube plus C1 x square plus C2x plus C3 is equal to 32x cube. Now we have to solve this to get the value of C0, C1, C2 and C3. So how do you solve it? You have to compare the coefficient of different degree term. So if you look at the right hand side, we have the coefficient of third degree term, that is 32, and in the left hand side there is just one third degree term, that is C0. So C0 will become 32. Then in the right hand side there is no term of x. So the coefficient of x will be what? From this I am getting a 6 C0, and from this I am getting C2, right? So 6 C0 plus C2, that is equal to 0, because there is no x term. Actually before that we also need to compare the x square term, so no problem, let us compare x square. So here we have x square coefficient, that is C1, and there is no x square term also, so C1 will also be equal to 0. Ideally this should have been written earlier, but I missed it. No problem, there is no mistake here. Now constant term, so constant term is 2C1, so 2C1, and here the constant term is C3, so 2C1 plus C3 is also equal to 0. Now if you look at C0, from this equation I can get C2, that is minus 6 C0. So 32 into minus 6, so that will give me minus 192. C1 I already have got 0, no problem. And what is C3? C3 is minus 2C1 and C1 is 0, so this will be equal to 0. So the particular integral part that I wanted to get, and for that I have selected this trial solution, is what? The particular integral part is ypx is equal to C0 is 32, so I got 32x cube. C1 is equal to 0, so there is no x squared term. C2 is equal to minus 192, so I will get minus 192x, and C3 is equal to 0, so there is no C3 term. So this is what we have got. This is the particular integral. So what will be the general solution? The general solution will be y is equal to complementary function, that is a cos x and plus b sin x and plus the particular integral, which is 32x cube minus 192x. So this is how the method of undetermined coefficient works. So let me quickly repeat the process. The process is that to find the general solution, you write CF plus PI, which we are doing it in all kind of problems. How to find CI, that also there is no confusion. And once we write the CF, the next task is to find the PI. To find the PI, we start with a trial solution. How do we write the trial solution? We look at the right hand side and see what kind of function is this. To write the trial solution, we have to keep this table in mind. And how to keep this table in mind? That also I explained, that we write all possible differential coefficient. If you are not getting this idea that all possible differential coefficient, just keep this result in mind. So once we get this trial solution, so since we had a degree 3 polynomial, I wrote a general 3 degree polynomial C0 x cube, C1 x square, C2 x and C3. Then taking this as a trial solution, I have to satisfy, or I have to substitute that in the given differential equation, and to by doing that, what we get the different coefficient which were initially undetermined, and we have determined them, right? So this is the process. Okay, so I think I managed in just one page, so no need to this. Now look at this problem. And in this problem also, what we have to do, we have to solve it. So to solve it, we will write the complementary function plus particular integral. To find the complementary function, we will write the auxiliary equation. So the auxiliary equation is m square minus 2m minus 3 is equal to 0. So we factorize it. We write m square minus 3m plus m minus 3 is equal to 0. So this will give me what? This will give me m can be taken common. So I will get m minus 3 plus 1 can be taken common. So I will get m minus 3 is equal to 0. So this is like m minus 3 into m plus 1 is equal to 0. So this gives me m is equal to 3 and minus 1. So the complementary function part is c1 e to the power 3x plus c2 e to the power minus x. Okay, so I believe that up to this things are absolutely clear. There is no confusion till now. Okay, but the next part is to select the particular integral, that is the trial solution ypx. Now as I have told you that in the right hand side there are two terms. One is e to the power minus x and another is minus 8 e to the power x. So when we have a exponential function, for e to the power minus x, I will select a into e to the power minus x, because this is what we have to do. If we have a exponential function, we write c times e to the power minus mx. Now some of you might be thinking why we are not considering this constant c, because since we are selecting an arbitrary constant, we don't have to write this 6th term, because the a term itself will accommodate that 6, because a is the arbitrary constant. I hope you got it. So we are not looking at it like 6 multiplied by e to the power minus x. Actually it is an exponential function. If a constant is multiplied, it should not be written here, because if you write it here, that will become 6a. So 6a itself is a constant, right? So 6a itself is a constant, means what? That we can replace it by another constant. So I just wrote a e to the power minus x, and similarly for this I will write plus b e to the power x, right? Because there are two terms, so we have to separately write for both the terms. So this is the first thing, that if there are multiple terms, we have to write the contribution for each of the term. Now the second thing that is very important here to note. Now if I look at this trial solution, we have a term of b e to the power x. We do not have any term of e to the power x present in the complementary function. But if we look at this term, that is e to the power minus x, that term is also present in the complementary function. You can see. So if you look at these two terms, they will become the same thing, like just arbitrary constant are different. So that can be replaced by just one arbitrary constant if you write this plus this. So when this term e to the power minus x is also present, what I need to do? I need to multiply it by x, or a suitable power of x. When I say suitable power of x, means that suppose in some problem x e to the power minus x is also present in the complementary function, right? Just for sake of argument, I will delete it later. Suppose this term is also present, x e to the power minus x multiplied by some other constant. I mean, don't get confused that how it will be possible, because this is a second order differential equation. I'm just writing to explain this. So if this is also present, some constant time this, then here I will not write x e to the power minus x. I will multiply it by x square e to the power minus x. I hope you got this. Yes. So let me remove this, otherwise it will create confusion. Now once I have got this as trial solution, I have to satisfy the original equation. So to satisfy the original equation, what we need to do? We need to find yp double dash and yp dash. So first of all, what is yp dash? So I have to differentiate this. X is the first function. Derivative of e to the power minus x will give me minus e to the power minus x, and plus e to the power minus x is the second function. Derivative of x will be 1, and plus this will just remain b to e to the power x. Now I need to find yp double dash. Yp double dash. So the first term is like minus a x e to the power minus x, so I can take minus a, and again we have to differentiate this. So x is the first function. Derivative of e to the power minus x is minus x e to the power minus x, so I took minus here. Then again e to the power minus x, so e to the power minus x. Derivative of x is 1. Okay, so this is the for the first term. Then we have the second term also, a e to the power minus x, so that will give me minus a e to the power minus x, and we have b e to the power x, so that will give me b e to the power x. I hope there is no doubt in this. So to get the constant a and b, what we need to do next is we need to substitute these values in the equation. So what I will get, or can we okay, let me write directly. So yp double dash, so this minus a and this will become plus, right? So we will get ax e to the power minus x, and minus minus a e to the power x and minus a e to the power minus x. So minus 2a e to the power minus x plus b e to the power x. So that is our y double dash. I hope you got it. This minus and minus will make it ax e to the power minus x, and this minus a e to the power minus x, and this will make it 2a e to the power minus x minus 2y dash. So we have to multiply this. So it is already a minus, and this minus will make it plus 2a x e to the power minus x. Okay, and then minus 2 a e to the power minus x, and then minus 2b e to the power x, and then minus 3y. So I write it here. So minus 3, and y is 3a x e to the power minus x, and minus 3b e to the power x, and this whole thing is equal to 6 e to the power minus x minus 8 e to the power x. So let us simplify the terms. So if you look at this term here, it is a e to the power minus x, and it is 2ax e to the power minus x. So a plus 2a is 3a e to the power minus x, and minus 3a e to the power minus x. So this term, and this term will cancel. Now if you look at this term, we have minus 2a e to the power minus x and minus 2a e to the power minus x. Okay, so I will get how much? I will get minus 4a e to the power minus x, and b e to the power x, and minus 2b and minus 3b. So it is minus 5 and plus, so it will become minus 4b e to the power x, and if I compare it, it is 6 e to the power minus x minus 8 e to the power x. So by comparing, I will get what? Here the coefficient is 6, here the coefficient is minus 4a, so I get minus 4a is equal to 6, and here the coefficient is minus 8, and here it is minus 4b. So minus 4b is equal to minus 8, sorry, not 8, minus 8. So b will be equal to 2. This b will be equal to 2. Let me rewrite, because someone who will see it later will get confused. So it is like minus 8. So from this I get b is equal to 2, or from this I get a is equal to 6 by minus 4. So that is minus 3 by 2. Right. So what is the particular integral? So the particular integral is ypx is equal to a, that is minus 3 by 2x e to the power minus x, and plus b, so that is 2 e to the power x. So if I can write the general solution, the general solution will look like y is equal to c1 e to the power 3x plus c2 e to the power x minus 3 by 2 x e to the power minus x plus 2 e to the power x. So I hope the process is very much clear to you. So from the next problem onwards, I am not going to solve it, or I will see that, I mean, let me do some more problem solving. Depending upon the nature of the problem, I will solve it, or I will leave it for you to complete. Okay. Okay, so the next problem that I am going to solve is this: y double dash plus 9y is equal to cos 3x. So as usual, we will write the solution as y is equal to CF plus PI. To find the CF, the auxiliary equation is, what is the auxiliary equation? M square plus 9 is equal to 0. So this will give me m is equal to plus minus 3i. So what is the complementary function? If I write ycx, because we are using the term ypx, so don't get confused, I can write complementary function, and here I write, suppose c1 cos 3x plus c2 sin 3x. I hope why do we write this? You already know that if the roots are imaginary, then this is how the complementary function is written. Yes or no? Now the next thing that I want to talk about is that how to find the trial solution, or ypx. So what is ypx? So if you look at the right hand side, the right hand side is cos 3x, and when you have cos 3x, what you write as the trial solution? You write a cos mx plus b sin mx, right? So here you will write the trial solution as what? You will write the trial solution as a, because c1 c2 constant I already have used, so I will write a cos 3x plus b sin 3x. But one thing I note, that when I am writing this as the trial solution, a cos 3x term means cos 3x terms is also present in the complementary function, and sin 3x term is also present in the complementary function. So whenever we have a situation like this, we try to make the particular integral independent of the complementary function. So for that we multiply by x or suitable power of x. So here by multiplying by x we can manage. So I just multiplied it by x and I got a cos 3x plus b sin 3x into x. So this is the trial solution in this case. Now again, how to solve this? So to solve this we have to differentiate it and substitute it in the original equation. So should I do it or should I leave it for you? Let me do it. This is the last problem. The video will become this is the last problem where I am going to find the undetermined coefficient, because the main task in this kind of problem is to be able to correctly select the trial solution. And it has been seen earlier that especially in multiple choice question they ask questions related to that what is the possible trial solution to find the particular integral, right? And in this question basically if you look at they have asked us to find the trial solution only, but I am going to find the general solution. So in the question I already have answered, but just for better understanding of the process I am going to differentiate it. So what is yp dash? So now there are two functions x and, so I write first function and the differentiation of the second function. So if I differentiate it I will get minus 3a sin 3x and plus 3b cos 3x, right? And plus the second function, that is a cos 3x plus b sin 3x, and the derivative of x will become 1. We need to find y double dash, means we need to find yp double dash. So again first function is x, I need to differentiate this, so it will become 3, so minus 9a cos 3x, and it will become minus 9b sin 3x. I hope you understand the derivative, and plus the derivative of this I already did. So the second function, that is minus 3a sin 3x plus 3b cos 3x, and then the derivative of x is actually 1, right? And now I have to differentiate this also. So plus minus 3a sin 3x and plus 3b cos 3x. So once we differentiated, now substitute it in the original equation. So y double dash, so what is let me change the color for better visibility. So y double dash actually is minus 9 ax cos 3x minus 9bx sin 3x minus 3a sin 3x and plus 3b cos 3x, and then minus 3a sin 3x and plus 3b cos 3x. Actually I could have added them because they are similar term, but no problem. And plus 9y, so plus y is this, so I will write 9 times this, so 9ax cos 3x and plus 9bx sin 3x, and that is equal to cos 3x. So now let us see this term minus 9ax cos 3x, and this cancel, 9bx sin 3x, and this term is cancelled. Now we just have to simplify. So we are getting minus 3a sin 3x and minus 3a sin 3x, right? So minus 6a sin 3x, but there is no sin 3x term here, so it means that minus 6a should be equal to 0. Okay, and if you compare the other term, that is 3b cos 3x and 3b cos 3x, so it will be 6b cos 3x and cos 3x, so the coefficient of cos 3x is 1, so it will be 1. So what we got? We got a is equal to 0 and we got b is equal to 1 by 6. Okay, So what is the final solution now? Final solution is y is equal to cf. So cf I have got c1 cos 3x plus c2 sin 3x, and ai got 0. So ai got 0, so the particular integral will be what? Particular integral will be a is 0, so I will just get b. Sorry, yeah, just I made some mistake somewhere. Just let me check once. No, so it's all okay, no problem. I was just thinking something else. So here a I have got 0, so this cos 3x terms will become 0, and b I have got 1 by 6, so it will be just 1 by 6x sine 3x. So the pi will be 1 by 6, so I write plus 1 by 6 x sine 3x. So this is how the method of undetermined coefficient work. Now in the next problems I am not going to find the coefficient, I am just going to talk about the trial solution. So if you look at this problem now, find the trial solution for the particular integral of the differential equation. So if I just look at the right hand side, and the students make a lot of mistake, because I have told you that when I am writing the trial solution, I am not only looking at the right hand side, but I am also looking at the complementary function part. So if I have to write the general solution, y, I write ycx, that is complementary function part, plus ypx. Here I have written it slightly different, so that you are aware with all the notations. To find the complementary function part, you write the auxiliary equation, that is the auxiliary equation is, let me write it again, the auxiliary equation is m square plus 4m plus 4 is equal to 0. How to write the auxiliary equation? I believe that there is no confusion in that now, right? Now if you solve it, this is basically m plus 2 whole square is equal to 0. So you will get m is equal to minus 2 and minus 2. So if you write the complementary function part ycx, it will be c1 plus c2x, the roots are repeated, right? c1 plus c2x e to the power minus 2x. And I hope you understand that this can also be written as c1 e to the power minus 2x plus c2x e to the power minus 2x. I have deliberately written it like this so that you can see that there are two terms here. Now if I have to write the trial solution, that is ypx, if I just look at the right hand side, it has a function e to the power minus 2x, so it should be written as a e to the power minus 2x. Okay, but when I write it a e to the power minus 2x, you realize that that term e to the power minus 2x term is already present in the solution, so I need to multiply it by x. But when I multiply it by x, I realize that x e to the power minus 2x term is already present. So to make it independent, I have to multiply it by x square. So now the trial solution will be ax square e to the power minus 2x, and this is what I was talking about when I was giving this statement, that if any term in the choice of particular integral is also a solution of the corresponding homogeneous equation, that is a term in the complementary function, means if any term is already present in complementary function, then we multiply this term by x or by x to the power m if the term in the complementary function correspond to a multiple root of multiplicity m. So here, as you noticed, that this term x e to the power minus 2x is coming in the complementary function because we have a root minus 2 whose multiplicity is 2, means that root is coming 2 times, minus 2 is coming 2 times, so we need to multiply x to the power 2 in the trial solution. I hope you got this. Okay, now look at this particular problem. So here again I am not going to write the general solution, I am just going to write up to the trial solution part. So how do you write the solution? You write the solution ycx plus ypx. Okay, and to find the ycx you need to write the auxiliary equation. So the auxiliary equation is, and ladies and gentlemen, some students do not write the complementary function and then they directly just look at the right hand side and write the trial solution, and in that case, as you have noted, that there is a scope of mistake being committed. So be careful. So the auxiliary equation will be m square minus 4m plus 13 is equal to 0, and its root will be minus b, so that is plus 4 plus minus b square, so that will be 16 minus 4 into 1 into 13, 4ac by 2a. So I will get what? I will get 4 plus minus 16 minus 52, that is minus 36, so that will give me 6i by 2. So 2 can be taken common. I will get the root 2 plus minus 3i. So what will be ycx, the complementary function part? That will be e to the power alpha x, that is e to the power 2x plus 2x, right? And c1 cos beta x, so beta is 3, so c1 cos 3x plus c2 sin 3x. Okay, so this I already have written. Now what will be the trial solution ypx? So as you can see that here it is a function of e to the power ax sin bx, and I just want to show you the main slide. So if you have something like e to the power ax sin bx, you take the trial solution as e to the power ax cos bx plus c1 cos bx plus c2 sin bx. So what should be taken here? The trial solution. The trial solution should be taken here e to the power 2x. c1 c2 I already have used, so let me use another constant a cos 3x plus b sin 3x. If I look at the right hand side, e to the power 2x sin 3x, so basically it is in the form of e to the power ax sin bx. So the trial solution should be written as e to the power ax a cos bx plus b sin bx. So that is what the trial solution will be. But one thing you note, that the trial solution, that, and I hope you have already been clear about this, that 12 is a constant, so there is nothing to be multiplied here for 12, because the coefficient that we are selecting here, there are arbitrary coefficient or arbitrary constant, so they will be adjusting with the term 12, right? So but the important thing is that if you look at the complementary function and the trial solution, both are same. So we have to make the trial solution independent, and to make it independent we need to multiply it by x. So this is a mistake which a student will commit. They will not multiply it by x and they will consider this as the trial solution. But as you can clearly see, the trial solution is nothing but the complementary function thing. So we can't do the same thing if we are getting something in the trial solution which is already present in the complementary function. In that case, we need to multiply the trial solution by its suitable power of x. And what is the suitable power of x? It will depend upon the multiplicity of root, as you have seen in the previous problem. Okay. Now quickly take two more problems. So let us first look at this one. Write the trial solution, and now I am just focused on trial solution for the particular integral of the differential equation is this. So in general, when we write the general solution, we write ycx, the complementary function part, and then ypx, that is the trial solution or particular integral part. Particular integral part, trial solution we take to find this ypx. Now if I write the auxiliary equation, what is the auxiliary equation? Auxiliary equation is m cube minus 2m square minus 5m plus 6 is equal to 0. And I am not going into the detail of finding the roots. I would leave this for you. If you take m is equal to 1, you can clearly see that m is equal to 1 is a root, because 1 minus 2 minus 5 plus 6 will become 0, right? So m minus 1 will be a factor, right? M minus 1 is a factor, and then you can use the synthetic division to find the other two roots. So the roots in this case, and I hope you know how to find it, will be 1 and minus 2 and 3. So what will be the complementary function part? The complementary function part will be c1 e to the power x plus c2 e to the power minus 2x plus c3 e to the power 3x. So this is the complementary function part. Okay, now we have to find what? We have to find the trial solution, that is ypx. So how can we find the trial solution? The ypx, that if you look at the right hand side, it is 18 e to the power x, so it should be a e to the power x, right? But as I have told you earlier also, that when we write the trial solution, we also look at the complementary function part, and we realize here that this term e to the power x term is already present in the complementary function. So I need to multiply it by a suitable power of x, and because this is corresponding to the root 1, and root 1 is coming once in the auxiliary equation, so I need to multiply it x to the power 1. So now this will be the trial solution. Okay, quickly let us look at this particular problem. So I am not going to write all the details. You can clearly see that the auxiliary equation will be m cube minus 6m square plus 12m minus 8 is equal to 0, right? And I don't know how many of you can clearly see this is actually m minus 2 whole cube. I can write it m cube a cube minus 3a square b, so 3 into m square into 2 plus 3 into m into 2 square minus 2 cube is equal to 0. So this is just m minus 2 whole cube is equal to 0. In case if you have doubt about it, that's just do the way you want to find the root, but make sure that you are getting the right roots, that is 2, 2 and 2. So if I write the complementary function, the complementary function here will be c1 plus c2x plus c3x square and e to the power 2x. That will be the complementary function. Yes or no? Now what will be the trial solution? So the trial solution will be ypx is equal to, if I look at the right hand side, we have e to the power 2x, so I will write a e to the power 2x, and we have 27 e to the power minus x, so I will write plus b e to the power minus x. But as you note that in the complementary function we have e to the power 2x, and this e to the power 2x is coming because of the root 2, and this 2 is coming 3 times. The multiplicity of the root 2 is 3, so if I multiply it by x, x e to the power 2x is also present. You can see x e to the power 2x. If you multiply it by x square, that is also present. So you can't multiply it by x or x square, you need to multiply it by x cube. So the trial solution will be a x cube e to the power 2x plus b e to the power minus x. And once you get the trial solution, you know how to find the coefficient a and b. You have to differentiate this suitable number of times and substitute it in the original equation, and then compare the coefficient and get the solution, right? So it is not very direct. You have to put a lot of efforts to get this constant, but I hope the process is clear to you, and I also have explained through multiple examples. So I believe that the method of undetermined coefficient is clear and you have understood everything. In case if you have enjoyed the video, like it, share it, and share with all your friends. Thanks for watching.